Thank you, David.
I'm
KB, we all ready?
Anthony, do you have presentation rights or screen sharing?
I can invite to share the screen. Let's see if I can do that for.
Okay.
This is just learning, and I apologize. Maybe
Karina could do it, I think, because
Yeah.
she's the actual admin.
I can invite Karina and Benjamin Branch.
Yeah, but Karina, I believe, created the meeting, so she's the only one that has the admin credentials to elevate people to present or to for those folks.
Karina, are you able to do that?
Here, let me look really fast. Who's the current host? Anthony?
Anthony here.
Okay. Anthony, can you drive presentation for Ben?
I can share my screen.
Okay.
I'll just send you the link real quick to it.
Thank you. We'll troubleshoot later. Just want to make sure we're 11 minutes in.
There you go.
Just give me a second. I'm bringing it up. I need access.
Yep. That's how I just created it this morning. All right, go ahead.
Okay. So this just shows that we're all just putting in the effort and trying to make this better. Let me share my screen. Can you see it?
It says loading for me.
Okay, then perfect. Because that's what it says for me too.
Okay.
Better?
Nice. Looks good. Yeah, so I just finished my introduction. So I'm Ben, been with Red Hat about 5 years. Focused on edge computing, and I work with well, pretty much everybody here. I think I've met just about everyone here from Red Hat. And so last time we talked about what we called the onion slide, which was how or so different layouts of what you can expect, what different layouts of edge look like. I'll just recap that real quick in this, and then we'll talk about topologies. And I've got more slides, so we can do more, we can do less. Feel free to interrupt. We've got a lot of good technical knowledge on this call. So why don't you skip the next slide? That's just what is edge. I think we've got a pretty good idea, of what edge is. Just to recap, so edge brings with it some different challenges that you may not find in a data center. So, if we just take a data center, you've got a bunch of clusters, and they're all the same, and they're all big, and they all have cooling, and the power is always on, and the internet never goes out, and it's just a great place to be. And with the edge, a lot of these things can vary a lot. So maybe you don't have a lot of space. Maybe it's really small. Maybe it is mobile. It has to fit in the back of a truck. Maybe your connection is slow or super latent or just not there. Sometimes it's up, sometimes it's down. Maybe you need to be offline and you don't have any sort of internet connection. Anyway, not going to go through all these, but anyway, there are a lot of variables that you either may not have to deal with it in a data center, or you do, but they're different or they're more challenging. So these are really just good things to keep in mind as you're building it out. Don't just take things like electricity for granted, because you may not necessarily have it in all places. So let's move on to the next slide. And this is, and this is the one that we kind of spent time on last time. Basically, the bigger the stuff, the bigger your servers, the bigger the nodes, those are going to go on the right. So they could be in a cloud, they could be public cloud, they could be your data center. That's where it says enterprise. As you move out to the near edge, they can still be fairly big. It can still be like a 1U, 2U node kind of thing. So we're saying roughly this big or so. Still fairly big, but not racks and racks of identical servers. And then as you get out to the far edge, that's where things start getting really small, and where things like power, cooling, connectivity, all those things, those can start to vary a lot. And then beyond that, of course, are the actual sensors. So if it's a camera, thermometer, a robotic arm, the actual things that are either doing the work or measuring the work being done. So I won't spend too much time here, but does anybody have any questions on this slide, just so we're on the same page? All right, cool. Let's move on to the next one. So this slide is very, this, if you're reading the last one from right to left, you can also read this one from right to left too. So again, you've got, if you're looking at a cloud or private data center, some actual big area where compute is being done, or things are being stored, you're going to have big rack mount servers. So you can see, operation, like factory operations. You've got plenty of room. It could be, in a private data center for a factory, or in a really big place on site. As you get smaller, so the middle section there, again, we're moving from right to left. These are going to be in that kind of like middle area, right? So they're definitely smaller than a rack mount. It's not so small that it's going to fit in your hand like the one on the left, but these are definitely smaller footprints. So if you're thinking like those small form factor PCs, like that kind of size. The ones in the picture are, it's actually a partner we've worked with, I believe, if I'm looking at it right. We've used them in a couple demos. Those are fanless, as you can tell by the heat sinks, so they're quiet. They can work in places that are dusty, or if you've got metal bits in a factory flying around, you're not going to get that sucked in through your fan. So those, they're not waterproof, but you're not blowing air through them. Kind of passively cooled. But still slightly bigger than the ones on the left. The ones on the left, we're going to call gateways or endpoints. These are really small. So these are really right on site. You can see that some are, they could be solar powered. Maybe they could have batteries. They're very small. Maybe they're in a vehicle, for example. Devices and sensors I like to leave up here crossed out, and that's just a reminder that from a Red Hat perspective, we're not talking so much about the sensors or the things doing the work themselves. Those are kind of best left to an open ecosystem of partners that can really focus on those. And Red Hat, we kind of tie those together, right? So we're all the actually, can we jump back one slide? I'll just show where we fit in. If we're talking about this little place, it's that red line on the far left with the hat. Basically, we're connecting all of the sensors, but again, you're not going to find a Red Hat thermometer or a camera or something like that. Anyway, we can go back to that slide. Does anybody have any questions on this?
Where you were at the dotted red line, is
Mhm.
that where Kafka or connecting to the sensors? Like if you have 1,000 sensors out there on the edge, is that out there?
Let me defer to either Daniel, Mark, or Henri on that one, where you'd use Kafka. Any of you guys have a thought?
Sorry, I need to find the unmute button. So the question is on when we use Kafka?
Yeah, if we actually, I guess we go back to the onion slide,
Yeah.
where that would fit in.
So the simple answer is, if you go back to the onion slide, you see that big arrow. I usually say it like, so edge computing is a lot about shoveling data from the left-hand side to the right-hand side, from the edge location, far edge, near edge, somewhere to the core. And one really good tool and vehicle to take care of this data shoveling is Kafka, because you need to fight things like intermittent connectivity. And that is where Kafka is really a good job doing. So for example, running a Kafka broker on the far or near edge location where you accumulate the data. And then when you have connectivity back to your core systems, then Kafka takes care of shipping all the accumulated data over to the core systems. You can utilize, for example, Kafka Mirror Maker to do so. So it is really easy to have like hundreds or thousands or tens of thousands of edge devices, each with a Kafka broker, shoveling data to the core systems. And that is one of basically event-driven mechanisms where Kafka comes really nice into play and is way better than, for example, MQTT. Because in MQTT, if you use traditional message brokering, there is a high risk of losing some data. And Kafka with these event sequencing is really good in handling outages. That's one of the examples.
I think, David, you have your hand
Yep.
raised.
Yeah, I was going to ask a question for Ben and or anybody else from that standpoint. Where does Red Hat mobile device or mobile come into play from your onion perspective?
Is
If you go back one,
device edge?
I'm not totally sure. I looked at it's one of the Red Hat offerings. If you go like to the the main portal for access.redhat.com and you go into the software, it will offerings. It says Red Hat Mobile as one of the offerings, and I didn't know if it was part of the far edge or if it's part of the sensors and actuators part. And how would that fit in? Because that could be possibly a sensor, it could be possibly an actuator, it could be whatever from Red Hat Mobile or Red Hat Mobile. I can get you the link, Ben, if you want me to, so you can take a look at it.
Yeah, do that, and then I can check it out. Maybe.
Is that Red Hat mobile application platform?
Yep.
Yeah, I remember that, but I think that is a discontinued product.
That used to be Feed Henry, and that's discontinued it.
I mean, if it is, it's in the access.redhat.com portal, and it looks like it's an actual. I mean, I don't
Please
say
show me
yes
the
or
link.
no.
We have to fix that.
Sure. Give me a second. Hold on, I'll send it to you. Stand by. But yeah, it's in there, and I'm like, okay.
I mean, it would fit in if your far edge, if you consider this as a mobile device, for example. Yeah, there's a mobile application, but nowadays it's so much easier to write apps. But yeah, you actually don't need Feed Henry or a mobile application platform.
And that's the question I was trying to ask it. And is it says mobile, Red Hat Mobile in there, and I'm like, where's that fall into?
And we usually basically we start really good where Red Hat Enterprise Linux starts, because that is the minimum system footprint, and that is also, for example, why here the sensors and actuators is grayed out, because Red Hat Enterprise Linux simply is, first of all, 64 bits. We don't do any 32 bits anymore, so all these small microcontroller stuff is out of the game for us. And then we need like 1.5 gigabytes of RAM and a core for Red Hat Enterprise Linux. And that is kind of the minimum system footprint where we actually start to play around. So we start to talk about something like this here. That is typically stuff you can boot RHEL on.
Okay. With that said, do you want me to move on? We'll get to the actual topologies. Thanks, Daniel, for dropping in. Okay. Yeah, Anthony, if we can move to the one after this one. So this is the topology slide. And we can just kind of pause here. It's similar to the onion, where the bigger things are on the right. So if we look at the right column at the bottom, it says clouds or data center. Same as the middle of the onion there. Then you've got where it says decentralized data center, those are going to be the smaller areas. So that would be like that near edge. And then the column on the left is, I guess what it would have said, far edge. So this also reads, so it's right to left, big to small. To an extent, it's also bottom to top, big to small. So if we start at the bottom, this topology, 3-node cluster, it's still OpenShift, but instead of running it in a cloud or a large data center, you can run it on what we call a compact cluster. So 3-node cluster, it's got high availability. When we say low footprint, it's kind of low footprint relative to a whole rack of servers. So, three nodes might be roughly this big. If my hands are on the screen. And you still get high availability. So it's full OpenShift, all the great features, but slightly smaller. So you could run it offsite, kind of near where the work's being done. Not right there necessarily, but nearby. We move, and you can also see that the corresponding requirements on the right. So 3 cores, 24 gigs. Not a lot, your laptop might have more than that. Nevertheless, it's still it's still larger than the ones that are up top. The next one up is remote worker nodes. These are interesting because you still have the control nodes, the control functions in those kind of near edge data centers, but now the actual worker nodes can be done on site, can be put on site. And so that lets you, let's say you've got, a slightly less space than you would need for the 3-node. You can just have a single node right there. And also it kind of spreads out the requirements too for the hardware. So if you look on the right, 2 cores, 16 gigs of RAM, worker, 1 core, 8 gigs. So that could be a smaller node. One thing to keep in mind is that you really want that black arrow, that black link between the control and the workers. You really want that to be up and available. So while it's okay for the red arrows to kind of drop or go offline, and that's okay, you really want the black one to be on. So it's best for some kind of specialized use cases. When we move up one more, we get to single node. You'll probably hear it called SNO, single node OpenShift. This was the kind of the latest OpenShift from maybe about 3 years ago, roughly. And single node brings, like it says, it's a single node, puts it right on site. So it's really small. You've got both the control and the worker functions right there, right on site. So we're talking about 4 cores, 16 gigs, again, smaller than a laptop, not quite pocket sized, but pretty small. And it's great. You can put it in a lot of places, right? This really opens a lot of doors if you want to put it under a seat, in a vehicle or somewhere that doesn't have as much ventilation, where you may not have a full rack with fans because it's fewer cores, it's smaller, it's generating less heat. You can put it in smaller places. And also because you have the control and the worker functions right there, it's okay if you lose connection. So when we talk about intermittent connectivity, again, we'll just use a vehicle, pretend it's under a seat or something like that, on an airplane or a ship. It's okay if it loses connection for a little bit because it's got everything it needs right there. And then when it comes back online, it can resync back to a more central data center or cloud. And so again, these bottom three are three different topologies, flavors, sizes, whatever you want to call them, of OpenShift. But at the end of the day, it's still OpenShift. So if you've if you've ever messed around with it in the cloud or home lab or something, you pretty much already know what it is. We've just made it smaller and extended it out to the edge. So I can pause here again. Does anybody have any questions?
For your S&O, that's also going to be very important for the telco edge, right?
Yeah. Yep. Yep, it's good. Now, the one thing to keep in mind there too, that actually brings up a good point, because it is a single node. You're not going to have, there's one node, right? So if that went down or loses connection or something, that's it. It's different from a 3-node cluster where you have high availability. So when we talk about high availability for single node, yeah, you could restart the app, or it could do that, do that automatically. But it's not. If that node goes down, that was your node. So it's something to keep in mind. But yeah, telco, great use case. And I think as we find, there are so many different use cases for edge in general, whether it's telco, whether it's public works, whether it's safety, travel. There's so many times where you want to get the compute or the storage closer to where the actual work is being done, or where the people are, where the customers are, that you're not going to have a one-size-fits-all solution. You can't just say this one box or this set of 3 boxes is exactly what everybody needs for every single use case. So instead, we've got a couple different options. But the good thing is they're all OpenShift. So again, if you're familiar with that, you kind of already know what you're working with, and you already know how to use it. You just need to keep in mind things like, again, power, latency, connection, cooling, things like that. So that's great, and that's small. 4 cores, 16 gigs, again, handheld, but not quite in your pocket. And then this year we announced, or I should say back in November, we announced Device Edge, which is even smaller. So if we just look at the specs up top, there are 2 options. So there's either one that needs 2 cores, 2 gigs of RAM, or 1 core, 1 gig of RAM. And like what Daniel was holding up, they are very, very small. If you imagine something, imagine a phone with 1 core and 2 gigs of RAM, or 2. You're not even going to find that in a cell phone these days. So Device Edge is interesting because it actually combines 3 products into one. It's so it's running on RHEL, and that is the option on the left that says without Kubernetes, so it can run just RHEL. And then if you want, you can add Microshift, and Microshift is a lightweight Kubernetes that is basically, it's from OpenShift. You can think of it as like a smaller, lighter weight version of OpenShift. So you're still going to get Kubernetes, works in your core, works in your near edge, your far edge. It's still Kubernetes. It's just smaller. And the third part of that, because I said there are 3 parts, is Ansible. So Ansible is there for your management. So any questions there on Device Edge?
So I would assume your home labs are all, you have all of these in your home labs? Pretty much this type of capacity?
I think, so if you're asking me, I think finding a machine with 2 cores, 2 gigs of RAM, again, that's a minimum spec, but something like that is probably easier to come by if you're working in a home lab environment that's not taking away too many resources. It's not like you have to dedicate 8 or 16 cores to something big. These are really, really pretty small. But yeah, great size to mess around with at home.
So the question is, for the home lab, you can scale up and scale down, the amount of nodes that you have or servers on that. From a hardware standpoint, it's very hard to scale up or scale down, when you have a very limited amount of space, swap, which is size, weight, and power. If you're in the middle of something and you're like trying to figure out, how do I justify and or juggle the load especially with power standpoint, your home lab's a little different because you basically have to just plug it into the wall. Where if you're in the middle of someplace where you have to truck it in, then you have to take in consideration, power. Obviously, you can't just drop in a whole bunch of big blade servers and expect them to work off of a, is it maybe a 50 kilowatt generator? You'll kill it. So, when your home lab's a little different, Ben, as far as what you can do from your home lab versus your, in an edge standpoint, a true edge standpoint. That makes sense, Ben?
Yeah, it does. And I think, and I might have interpreted the question wrong, but if you want to just, test it at a home lab, I mean, I think those resources are pretty easy to come by. But to your point, if you've got it, in a vehicle and you've only got millimeters to spare or a certain amount of power, that's already going to rule out some of the bigger options, right? Like most cars can't fit 3 nodes under a seat, right? That would be a pretty tall chair. So your environment's going to kind of dictate what you can and can't use. You may not have power all the time. You may not have enough power to supply something bigger, in which case you'd go with something smaller, like device edge. But at the same time, if you've got a larger generator or power is not an issue, or maybe space size isn't either, then yeah, you could do full OpenShift too. The nice thing is it's still just Kubernetes, right? So no matter what you choose, it's still kind of part of the same ecosystem there. So I can pause here. I have more slides about what device edge is, so I can go more into detail about device edge, especially because I've got some great technical folks on board, or I can save that for another day. Got any preferences?
Device edge, I mean, that sounds great. I know I had a question about, I guess zero trust on the edge. Do y'all train for that already, or is that something that's still coming? Or because I thought I saw something on the Red Hat documentation they were talking about, I guess, zero trust everywhere or something.
I would guess that topic is worth at least a call on its own, if not a whole series, because that brings you into the domain of security at the edge, which brings a lot of different challenges. Like, for example, think about zero trust. And in the long term, yes, we want to have zero trust principles everywhere. But you are facing a whole lot of new issues, like, for example, can you make sure that you can trust that device which is located at the edge? How does it get there? How do you install it, set it up there that you can still trust it? How can you verify that it has not been tampered with? Especially, for example, if you can't even guarantee the physical integrity of that device. Think about it being the edge device being located in just a switching cabinet where there's just a small key in front of it. So it's not in a highly secure data center, but just a public accessible switching cabinet. So you have to face the fact that somebody steals the whole edge device. Now, what if there's an important private key on that? So all of these topics are, I think, worth a session on its own. And just to give an overview of the problems and ideas on how to solve that, there's no one single solution to all of these problems, but there are, to each and every detailed problem, there are different solutions. So I would suggest to have a dedicated session on that.
Okay. Dave, you have a question?
I do. I was going to say, that may be maybe a topic for the security SIG, if Karina wants to open that up this year, as a starting primer for security SIG, that type of thing. Because like I said, Daniel makes a good point where that's a huge rabbit hole to jump down through, because like you deal with security, you deal with devices, you deal with all sorts of stuff. It's just not a edge issue. It's a whole
Yeah.
ecosystem issue. I won't say issue is not the right word, but
And of course, there's a lot of overlap and interrelation. For example, you would use concept like a trusted, secure software supply chain, trusted application pipelines that you can trust the container images and build you deployed, which you want to do in the cloud and in the data center also. So you can reuse and apply same principles for that. Other topics are really specific to edge computing, like, for example, this secure device onboarding, where there are, surprise, surprise, that problem has its own standard. There is something called FIDO secure device onboarding, which is a standard provided by the FIDO Alliance. That specifically addresses edge device onboarding trust issue thing. And I would suggest to have, for example, one session giving an overview of the problems, and then we select on which sessions do we handle in the edge SIG and which one are generic and go to the security SIG, because sometimes there's overlap, sometimes it's specific to edge.
Okay.
can we
And-
table that?
Yes,
Ben, can we-
I think we will table zero trust on the edge, and we may also table confidential containers on the edge as well. I guess that'll be another rabbit hole to go down. How do you David, do you have any more questions? Does anyone else have any more questions?
I was going to ask the question if Ben has anything more about, Mr. Cohen has anything more about the device edge from his slide presentation. You know, I'm assuming, you know, we're all somewhat in agreements to go, you know, have him proceed if everybody's good, because we've still got 20 minutes and change.
Yeah, that works for me. Happy to do that. You know, we've got good people on the phone here to answer questions. So yeah, I can go through a couple more slides and just give you a pretty decent look. So just to make it clear for everyone, now we're all familiar with what OpenShift is, right? It's OpenShift Commons. Up at the top, device edge, that's the new thing. And I've got a couple slides on what kind of separates that from OpenShift and how the two are similar and how the two are different and kind of when to use which and why. So yeah, Anthony, why don't we go to the next slide? I'll go through the next couple ones pretty quickly. This is just a high level marketing slide. Again, it says you're combining Kubernetes and Linux. So you've got those three different products that it makes. It's small, right? So it's a very, very small 2 cores or 1 core. Flexible, again, you can use just RHEL or you can add microshift. You can start with just RHEL and you can add microshift later, or you can start with both of them at the same time, whatever works for you. So flexible. Yeah, and of course, future-proofed, right? So these are operating systems and a platform that have been around for a long time. We've supported them for a long time, and so they'll be good for a long time. So let's move to the next one. The next one is just a super high level graphic. Again, 3 parts. There's the RHEL, there's the Ansible, and then there's the microshift. And that's what makes up the device edge product. The next slide, I might even see, Daniel, if you want to, oh no, sorry, it'll be the one after that. But this one's good. This is just an example saying, again, if we've got the big stuff on the right, the small stuff on the left, you've got those 3 node clusters, which are the biggest, then remote worker nodes that are smaller. Single node is the smallest OpenShift. So if we're talking just OpenShift, nothing else, single node is going to be the absolute smallest. When you get down, still using Kubernetes, there's the device edge with microshift. And then on the left, there's device edge without microshift using Podman and RHEL. And so those are 2 different options. And those are the smallest. Those are the ones that are 1 core, 2 core. So again, very similar to the previous to the 2 slides ago, just showing larger to smaller. Next slide.
What's your Ben, that slide that you just had?
Yeah.
What's the breakpoint there's like a big, huge, how do you call it?
A gap.
Yeah, thank you. I was drawing a blank there for a second.
Yeah,
So
yeah.
that,
So
what's the
that's
gap
really more
for?
that's more of a formatting thing. What it would really look like, another way to picture it is, I need two things that are parallel here. Basically, if you've got a line here and a line here, there is some overlap where you can have a smaller single node or a slightly larger device edge. Daniel, do you wanna jump in here?
Yeah, because actually the breakpoint here is simply the product you have to buy. It's a logical product grouping, because if you want to use Red Hat Device Edge with Podman or with Microshift, you have to buy Red Hat Device Edge. That is it has a stock keeping unit. You can actually order and you can buy the subscription for that. Or if you're on the right hand side, it's OpenShift, and that is why there is a small gap, because the logos really apply to the different products. And then, of course, there's plenty of technical difference, which we will see on the next slide.
Yeah, the question I was thinking, from that standpoint is your gap here would be maybe like swap size, weight, and power?
No,
Would
it's way more complicated. It's actually, first of all, product size, and then there is also a huge gap in functionality, or not gap, there's a difference in functionality. And maybe if you go to the next slide, I can quickly explain that a little bit, because I'm the product manager for both sides. So I created that slide. That's why I love to talk about it. So
Fair
the
enough,
design
Daniel, fair enough.
approach of the left-hand side, where you have Red Hat Device Edge with Microshift, the design approach is really start with nothing. We'll take an empty system and then add just the necessary components to get to Kubernetes workload portability. That is what you see on top, the gray boxes. That is your workload. That is your microservices application, pods, machine learning model in containers for model inferencing you would like to run. And that is really the goal of Microshift. So it is a bare minimum Kubernetes distribution. It is Kubernetes certified, by the way, but it is just enough to run your workload. And you can see basically the services are listed there. It's Kubernetes itself, of course, it's networking, an ingress controller, a little bit of storage, and that's it. So all of that is derived from OpenShift. So we reuse, for example, the ingress controller and router stuff from OpenShift. That's the same binaries, but really just the bare minimum. And if you compare this to OpenShift, a single node OpenShift cluster, there the design approach is it walks like OpenShift, it quarks like OpenShift, it is the same experience, but on a single box. And that makes a huge difference, because there's plenty of stuff which you have in OpenShift, which is not available in Microshift. And if you compare these lines, I explicitly ordered these lines that you can see the first stuff, networking, ingress, storage, that's the same. Yeah, that's on both sides. But then a lot of stuff is not there, like, for example, over-the-air updates, cluster operators, monitoring, logging. There is no console. Why would you add to all of your edge devices a web console, a fancy user interface? You need this for developers if you will work with a platform. But on an edge location, why should an end user log in to your Kubernetes cluster? They would log into the application, yes, but not to the administrative interface. If you have like 1,000 of these edge devices, you don't want to manage them manually by logging into a console. You would like to have this centrally managed using GitOps, using ACM, stuff like this. And that is why it is not there on the left-hand side. If you see the console on the right-hand side, it is listed. On the left-hand side, it's not there. And no, there's no way to add it. It is really on purpose not there. And that is a big difference. And the last really important difference is notice the tiny gap on the left-hand side between the Microshift part and the RHEL part. So on Red Hat Device Edge, you are in full control of the operating system, which is on the one hand side good news because you are and can take full control of the operating system. On the other hand, it's a little bit of a bummer because you have to take control of the operating system. So you have to make sure it's the right version, it's configured correctly, all of that stuff. That is on the left-hand side. And on the right-hand side, it is, as you are familiar with OpenShift, it is a tightly coupled Red Hat Core OS is baked into it. It's highly optimized. It's highly opinionated. We take care for you of the operating system. And that is also a big difference you need to be aware of.
Okay. I guess I have a question, and my question is I guess for a theoretical customer, a use case, you know, they want to do informatics, they want to do federated learning, they want to bring in the stuff from all the sensors, and the customer is new to this, and you know they hear about it, and I'm trying to understand how do we get a new customer to get into the using this, and so that they can understand the benefit and the cost savings of this, and how do you step a new customer through this process is what I'm trying to ask, where they want to be able to see their data, and maybe if not in the real time, then near real time analytics.
I mean, it usually really depends on what type of workload you would like to run on, what type of infrastructure do you have at your edge location regarding space, power, cooling, what are your, for example, high availability requirements? Because that is also a big difference between Microshift and OpenShift. Microshift is single node only. There's no way to scale it up to add additional nodes or to get to a 3-node compact cluster to provide high availability. That is the home turf and domain of OpenShift Kubernetes engine, which, by the way, you can also scale down. For example, you can disable the console and not deploy the console in OpenShift also to save on CPU and especially in this case memory requirements. But that is a big difference. Yeah, and then you try to basically meet the customer where they are. So where are they coming from? So for example, if they are coming from the cloud and want to extend to the edge, it's usually they have already some experience, are a little bit familiar with, for example, either container technology, Kubernetes, or even OpenShift. So extending that from the cloud to the edge, we call this hybrid cloud out approach. That is a natural idea to play around with OpenShift, for example, single node OpenShift. Simply deploy single node OpenShift to your edge device, play with that, use ACM for management, stuff like this. So that is the one hand side, hybrid cloud out. And the other approach is you might talk to a customer who is already on the edge, who does, for example, industrial edge computing, is in retail doing digital signage stuff like that. And they are more on they are already on the edge side and want to have all their different islands to connect to the cloud systems. So this is more the device edge in approach, hybrid cloud out versus device edge in approach. And for those customers, it's typically more easier. You start to talk about containers and they are overwhelmed and they say, hey, I just understood virtualization. So now you come with this something new fancy stuff again. So they could easily start with just RHEL and learn, for example, the container technologies with Podman. And then add Microshift Kubernetes only if they got their microservices architecture really to, I usually say you need Kubernetes orchestration typically if you have like more than 5 to 10 deployments, 5 to 10 pods. That's a simple rule of thumb. If it's just 5 pods and it's just statically run, use Podman system orchestration. It's good enough. Go just with RHEL. And don't worry, we have you covered, because if you later find out you would like to have Microshift, you simply add it on a later release. That's the beauty of the Red Hat Device Edge approach. And that is really the two high-level approaches to simply start where the customer is coming from, either from the cloud, extend to the edge, or if they are at the edge, extend to the cloud, join the cloud
Yes, yes, I think my customers definitely had a crawl, walk, run approach. And I think the first thing to get them to is to satisfy their power. You know, if they have no power out in the remote, then I guess that's the first thing I need to come up with power. And we're thinking like solar power or something to you know, or with some type of redundancy in the power to so that the sensors can at least come back up at some designated time. Do you run into that type of situation?
Yep, exactly. That's it. Yeah, I mean that is why we have somewhere a different slide about understanding the constraints. So my definition of edge computing is usually pretty easy. It's like it's compute not in the cloud, not in the data center, but somewhere else, and some constraints apply. And these constraints are important to understand. So you need to simply understand what are the constraints. Maybe it is not power or space. Maybe it is skill. And that is what you need to understand. And then you naturally get into the discussion, understand the organization. For example, as I said, if they are overwhelmed with containers already, then Kubernetes is really mind-blowing and adds
Yes.
complexity you don't need, and it does not help. Yeah, and it does not provide value. So don't add it. Add it only if it is really helpful. If you have, for example, maybe they have a commercial off-the-shelf solution they want to utilize, which runs on Kubernetes or requires Kubernetes, and boom, Microshift is in there, or it is certified on OpenShift, and boom, it's OpenShift. So when you start the journey, you don't know where you end. You have to find out on the way.
Okay, that's very helpful. And I guess it would be very similar if on the edge there is some type of event-driven activity where this process triggers that process, you would still have to make sure your infrastructure is there first before you.
And which part has to run at the edge and which part would be better at the cloud? Yeah, usually you would like to centralize as much as possible and decentralize, run at the edge only what is necessary. Think about, for example, in industrial, you have this with manufacturing execution systems. Like it really depends on the time criticality. If you need to, you have 1 or 2 seconds to answer, hey, which color do I need to apply to this part? Then it's critical, it has to run on the edge. But if, like, for example, which job do I need to process next? And by the way, this job takes then like 5 hours to proceed. It is not that time critical. So maybe you would run that part in the cloud, maybe even as software as a service offering. It really depends, and you need to find out. And maybe it even changes from use case to use case you add.
Okay, so it sounds like with the customer, I need to make sure they understand their constraints and what data is mission critical and what data can we come back and do an analysis later when we get the data.
Do we have the slide on the constraints in that deck?
Yeah, they were early on. It was slide 3. Way back in the beginning. But yeah, we kind of looked at them right at the beginning. There are a lot of them. Yeah, that's the one.
That's a non-exhaustive list of constraints. You want
It's a good start, though.
Okay, we have about 3 minutes. I think this has been very, very helpful. Does anyone else have any questions? I do have one last question. And it's getting back to that far edge and the Kafka, and I assume that the Kafka is already set up to handle the NB IoT sensors that the spec that just came out. Isn't it there yet, or?
No, Kafka is just a generic message broker. It has its own protocol. You have different, what was the term for Kafka? Adapters, endpoints. You might need to have some transformations, for example, from MQTT to Kafka or whatever your sensor is speaking. So you might need a little bit of glue code to transform.
Okay. Okay. All right.
And also check out the system requirements. Kafka message brokers are not that small. They typically require a lot of RAM because it's a Java-based implementation still, I think. Not sure how far we are with a Quarkus-based Kafka broker. yeah, you
Okay.
might need to check if that is really the right weapon of choice. I would use it as if I would even increase my device size to use Kafka, because it really makes your life way more easier for this, especially if you have intermittent connectivity. Shipping data from the edge to the core and vice versa makes your life really way more easier.
Okay.
But it might not fit. I'm not sure if this is 2 cores, 2 gigabytes of RAM. I doubt that you would get a Kafka broker on this one running. So you might need to have something, some intermediate gateway, bigger device. It really depends on the architecture and the requirements.
Are there any other questions?
I got one plug for myself real quick, if I can. I'm just dropping this in the chat. We had a learning path come out, which is going to cover basically, it's a course about 1 hour, covers the edge, covers topologies, and it just came out like yesterday. So I just want to share that. But that's it for me. No other questions.
Okay. That's awesome. We'll make sure to put that in the notes to follow up. And thank you so much. And we want to, again, thank everyone for participating. And we want to invite you back so we can continue on with maybe some security on the edge, zero trust, confidential containers, and things of that nature, and continue this journey. So what we have coming up next, I think next week is going to be, well, in 2 weeks, Ben Cushing, I believe his topic is it's edge devices for emerging disease detections, something of that nature, in 2 weeks. And then 2 weeks after that, we have Chavo Grover and David. Do you remember his topic? He was going to set up some clusters for us on one of his systems. But we'll make sure we send that out to you. But again, we want to thank you for your awesome presentation, and we want to invite you back for the security stuff. And also there was I was sending stuff out about a NESD conference in Boston. Deadline has been extended to January the 19th. And so if we want to put out a poster and oral talk in the Boston area, that is good. That is good. I'll send that out in the Edge SIG. So if anyone wants to put that out, so we can have the OpenShift Edge stuff out into the into research and a way to attract more customers. It's the Northeast Decision Science Institute, and a lot of faculty, and I think it's near BU and near the BU environment. And you never know, we may pick up some more customers that way. Does anyone else have anything? Oh, for the conference link, I would definitely put it in the Edge SIG in a second, so that you can see the conference. Also, there is the NERC workshop has been announced, and so if we want to do anything for the NERC workshop, I forget when the deadline is, but I know we can sign up. So as a team, if we want to sign up for that, that's a really good thing we can do, and I'll put that in the SIG workshop as well. And then, let's think about Red Hat Summit 24, 25, and on, and any other opportunities. We can do a white paper or any other projects or anything else we can do to get customer facing as a team. That would be really, really good. Oh, tomorrow, platform engineering SIG, Josh Gavant, I believe, is talking about platform engineering tomorrow. So please join us again tomorrow. And guys, again, thank you so much. We're so thrilled for your great expertise and the time you took to share with us. And we look forward to the next event, and we will send everything to the Edge SIG. So thank you so much, and y'all have a wonderful rest of your afternoon.
Thank you.
Thank you.
Yes.
Bye, everyone.